A powder that costs roughly $1 a pound killed cholera, typhoid, and dysentery in Victorian London. It killed them in the trenches of World War I. It kills them right now, today, in active Médecins Sans Frontières cholera wards. It is legal everywhere. It requires no electricity, no prescription, no special training, and most people have never heard of it. Now, here's what makes this interesting. Proprietary portable toilet chemicals cost $15 to $30 per gallon, and they require constant resupply from the manufacturer. A single 50-pound bag of this powder costs under $35 at bulk pricing. That one bag could handle a family's sanitation needs for months, no resupply chain needed. By the end of this video, you will know exactly what this powder is. You will understand how it works at the molecular level. You will know where to buy it today with zero restrictions. And you will have the precise step-by-step protocol for using it to eliminate sewage-borne disease if the grid goes down. To understand why this was buried, you need to understand what it saved us from. Welcome. This channel exists for one reason: to recover practical, verified knowledge that institutions have let slip through the cracks. Not hype, not gear reviews, not fear. Actionable intelligence grounded in history and science that you can use. If that matters to you, subscribe now, because the kind of information you're about to hear does not get mainstream coverage. And there's a reason for that, which we will get to. Let us start where this powder proved itself under the worst conditions imaginable. London. 1800. Population roughly 1 million. By 1850, that number had tripled. 3 million people, and not one centralized sewer system. Human waste poured directly into the River Thames, the same river supplying drinking water. In 1832, cholera hit London for the first time. 6,000 dead in a single outbreak. It came back in 1849. It came back again in 1854. Each time, thousands died. And each time, the city reached for the same emergency measure: lime, quicklime, calcium oxide. The same powder produced for centuries by heating limestone in kilns at 900 degrees Celsius. By 1858, the crisis reached a breaking point. The summer heat turned the Thames into what Parliament itself called the Great Stink. The smell was so overpowering that lawmakers draped lime-soaked curtains over the windows of the Houses of Parliament just to continue working. Tons of quicklime were spread across the river for shore as a desperate stopgap. It worked well enough to buy time. That time allowed Joseph Bazalgette to design and build London's revolutionary sewer system, completed in 1875. But here is the detail that gets lost. Before the engineering marvel, before the infrastructure, the frontline defense was lime, a simple powder, dumped on human waste, killing pathogens on contact. Now fast forward to World War I, the Western Front. Imagine 10,000 men concentrated in a trench network. That many soldiers produce approximately 4 tons of fecal waste every single day. 4 tons. In trenches, with no plumbing. The military solution was the same one London had used 60 years earlier: latrine pits, dosed with quicklime after every use. This was not optional. This was doctrine. The 1918 United States Army Field Sanitation Manual stated explicitly that any commander who neglected field sanitation, and I am quoting the sentiment here, must necessarily be considered a failure. Military historians have argued persuasively that the latrine was as strategically important as artillery. Because disease, not bullets, had been the primary killer of soldiers in every major conflict before the 20th century. Lime in the latrine changed that calculus. That was over a century ago. So does modern science agree with what those soldiers and engineers already knew? Now, before I answer that, I want to mention something. Everything you are hearing today is drawn from a much larger body of research we have compiled in the vault. That is our premium resource. It contains deep dives across dozens of topics like this one, categorized, sourced, no fluff. If you want the full research files, sourcing documents, and extended protocols, the link is in the description. But right now, stay here. Because what the peer-reviewed research actually shows will change how you think about emergency preparedness. Modern science does not just agree with the historical record. It explains precisely why it worked. And the mechanism is more aggressive than most people realize. There are 4 distinct kill pathways. 4? Not 1. First, when calcium oxide meets water, it becomes calcium hydroxide. That solution reaches a pH of 12.4. At that pH, hydroxyl ions penetrate bacterial cells and denature proteins. They shred the internal machinery. Research published in the International Endodontic Journal documented this mechanism specifically. The hydroxyl ions disrupt cytoplasmic membranes. The cell cannot maintain its structure. It dies. Second, at high pH, lime triggers saponification. That is a chemical reaction that dissolves lipid membranes. It is essentially turning the fatty outer layer of a pathogen into soap. The Canadian Veterinary Journal documented this pathway in the context of livestock biosecurity. The bacteria's protective envelope is chemically destroyed. Third, The alkaline environment attacks peptidoglycan, the rigid scaffolding that gives bacteria their shape. Simultaneously, at pH 10 and above, viral nucleotides begin to hydrolyze. The genetic material of viruses breaks apart. They cannot replicate. Fourth, and this one was only recently confirmed, a 2022 study published in Colloids and Surfaces identified an additional kill mechanism, reactive oxygen species. The lime generates free radicals that cause oxidative damage to pathogens. This was a previously undocumented pathway. Another weapon in an already overwhelming arsenal. Now here is what that looks like in the field. In Malawi, researchers conducted trials on fecal sludge treatment using hydrated lime. The result? E. coli was reduced below detection limits within 1 hour at pH 12 and above, below detection limits within 60 minutes. Médecins Sans Frontières, one of the most respected humanitarian organizations on the planet, uses a 30% hydrated lime suspension as a standard protocol in their cholera treatment centers. This is not historical trivia. This is active medical practice. The Japanese Ministry of Agriculture, Forestry, and Fisheries recommends calcium hydroxide at a rate of 0.5 to 1 kilogram per square meter for livestock farm entrance disinfection as a biosecurity measure. The United States Marine Corps Field Medical Training Battalion still teaches quicklime latrine protocols to this day. There is a critical threshold you need to understand. The pH must reach 12 or above for reliable bactericidal action. And because atmospheric carbon dioxide gradually reacts with calcium hydroxide, converting it to inert calcium carbonate, reapplication is necessary every 2 to 4 weeks under field conditions. In laboratory settings at 10% concentration or above, bactericidal activity has been maintained up to 35 days. But in the real world, plan on reapplication. So if this works this well, if it costs this little, if it has been proven across centuries and confirmed by modern peer-reviewed science, why is it not in every emergency kit sold in America? Follow the money. The modern portable sanitation industry is built on proprietary chemical formulations. Those blue liquids you see in portable toilets, they are branded, patented, sold by the gallon, and they require you to come back to the manufacturer for more. That is the business model. Recurring revenue, brand loyalty, subscription resupply. Quicklime is none of those things. It is a commodity, non-patentable, non-proprietary, available from dozens of unrelated suppliers. There is no recurring revenue model, no subscription opportunity, no brand loyalty mechanism, no corporation can own it, which means no corporation has any incentive to promote it. And it gets worse. The Environmental Protection Agency's registration history tells a revealing story. Pesticide registrations for calcium oxide products were systematically canceled over decades, not because lime was found to be ineffective, there is no study making that claim, but because commodity products generate no registration maintenance incentive. No company is going to spend money maintaining EPA registrations for a product anyone can sell. Meanwhile, proprietary disinfectant registrations expanded. The formal marketplace shifted toward products that make someone money. Look at FEMA preparedness guides, extensive sections on food, detailed protocols for water. But post-grid waste disinfection chemistry, barely a footnote. The preparedness industry itself trends toward subscription services and branded kits, not $35 bags of century-old powder. Now let me be absolutely clear. This is not a literal conspiracy. No one sat in a room and decided to suppress quicklime. This is market-driven displacement and cultural amnesia. It is the predictable result of an economy that rewards proprietary products and ignores commodities. But the effect on you is the same. You were left without this information, and that gap could cost lives. If you have made it this far, you now know more about post-grid sanitation chemistry than most emergency managers in this country. That is not an exaggeration. If this kind of practical, verified knowledge matters to you, make sure you are subscribed. Share this video with someone who needs it. The Vault link is in the description for the full research archive. Stay with me. The step-by-step protocol is next, and it is simpler than you think. Before I give you the protocol, I owe you the limitations. Because this channel does not hide inconvenient facts. Quicklime is caustic. It will burn skin on contact. It will damage eyes severely. The Centers for Disease Control and the National Institute for Occupational Safety and Health classify it as a workplace hazard and recommend full personal protective equipment. Gloves, eye protection, at minimum. The permissible exposure limit for airborne calcium hydroxide dust is 2 milligrams per cubic meter. Work in ventilated areas. Do not breathe the dust. When quicklime contacts water, it generates significant heat. This is called slaking. The rule is simple and critical. Add lime to water, never water to lime. Reversing that order risks a violent exothermic reaction. Storage matters. Calcium oxide absorbs moisture from the air. If your supply gets damp, it begins converting to calcium hydroxide and eventually to useless calcium carbonate. Sealed, moisture-proof containers in a dry location. That is non-negotiable. There is one specific pathogen exception you should know about. Research published in the Canadian Veterinary Journal found evidence that calcium may actually stabilize the spore integument of Bacillus anthracis, anthrax spores. For virtually all other pathogens, Lyme is devastating, but this one exception is documented and you should be aware of it. The pH of your treated waste will degrade over 2 to 4 weeks as carbon dioxide from the atmosphere reacts with the calcium hydroxide. Reapplication is required. This is a maintenance protocol, not a one-time treatment. And finally, Lyme treats waste. It does not purify drinking water. You still need a separate water purification method. These are complementary systems, not substitutes. With those cautions understood, here is the exact protocol. You have 2 primary options, depending on your situation. Option 1, trench or pit latrine. Select your site a minimum of 200 feet from any water source. Position it downhill and downwind from your living area. Excavate a pit 4 to 5 feet deep, 1 to 2 feet wide. You can improvise seating with a plank across the pit or use a bucket positioned over it. After each use, apply approximately 100 grams of quicklime. That is roughly 1 cup. This maintains an alkaline layer on the surface that kills pathogens and controls flies. When the pit fills to within 1 foot of the surface, stop using it. Cover with at least 12 inches of compacted soil. Dig a new pit. Option 2, bucket and indoor emergency system. Line a standard 5-gallon bucket with 2 heavy-duty trash bags, one inside the other. After each use, apply 1 cup of quicklime directly onto the waste. When the bucket reaches half capacity, apply a generous final layer of lime. Seal both bags tightly. Store the sealed bags away from living areas. When conditions permit, bury the sealed bags a minimum of 200 feet from any water source. For bulk sludge treatment, the dosage is 10 to 17 grams of hydrated lime per kilogram of fecal sludge. Minimum contact time is 2 hours. You are targeting a pH above 12. At that threshold, you achieve a 6-log reduction. That is 99.9999% elimination of E. coli. The Humanitarian Sanitation Hub estimated the cost of this treatment at approximately 12 euros per cubic meter of treated fecal sludge in their Malawi field trials. Where to buy? Tractor Supply Company carries it. Industrial chemical distributors carry it. Amazon carries it. The standard size is a 50-pound bag. Bulk pricing runs roughly $34 per bag on a pallet of 42 bags. That is approximately 1 ton of lime. No license required, no restrictions, no purchase tracking. Storage is simple. Sealed, moisture-proof containers. A dry location. If kept dry, quicklime is shelf-stable indefinitely. It does not expire. It does not degrade. It just waits. The city of Ivins, Utah, includes quicklime in its official emergency sanitation guide, instructing residents to use it in a grid-down scenario. Municipal water treatment plants around the world use calcium hydroxide daily. This is not fringe knowledge. It is foundational chemistry. That is it. That is the entire protocol. Let us step back and look at what we have covered. From Victorian London, where a desperate city dumped lime on the banks of the Thames to hold cholera at bay, to the trenches of World War I, where military doctrine recognized that sanitation was as critical as ammunition. To modern Médecins Sans Frontières cholera treatment centers, where hydrated lime is standard protocol right now, today. To your home, your family, your preparedness plan. The diseases quicklime protects against have not disappeared. Cholera, typhoid, dysentery. They killed more soldiers in every pre-20th century war than combat did. They are not gone. They are held at bay by infrastructure. Infrastructure, most people assume, is permanent. It is not. A single 50-pound bag costs less than dinner at a restaurant. It never expires if stored dry. And the protocol can be taught to a child in 5 minutes. This is not exotic knowledge. It is not classified. It is not restricted. It is the foundational chemistry of human survival for the day the toilets stop flushing. And now you have it. If this information matters, and I believe it does, share it with someone who does not have it yet. Every person who learns this protocol is one less person vulnerable to the oldest killers in human history. The next entry in the vault goes deeper into another critical piece of preparedness knowledge that has been quietly displaced by the same market forces we discussed today. Link in the description. I will see you there.